So proving triangles similar to each other involve just three methods, okay? The angle-angle similarity, the side-side-side, and the side-angle-side, okay? So we're going to take a look at each of those methods, and we're going to look at some examples, and I'm going to let you guys work through some of them. And like I said, when you start seeing patterns, it's a good idea to, you could go back to this one pager, and you could kind of add those on there. All right. So the angle-angle similarity basically states that if two corresponding angles are congruent, so you have two sets of angles that are congruent, then you can go ahead and say that the triangles are similar. And I want you to think about that for a minute. So you've got two sets already congruent. What's going to happen with that third set? What do you know about triangles? They always equal 180, right? So if you've already got the two sets and they are equal to each other, that third set just automatically what? Falls into place, right? Because of the parameters of that 180. Okay, so that's kind of how this one works. Okay, so let's take a look at our first one. Okay, we have triangle ABC and triangle DEF. So let's start with triangle ABC. Find the measure of angle C for me, please. $31. Okay, so let's go ahead and just put that in the triangle. Now, I want you to compare the two triangles. Do we have two sets? Yes, we do. So let's go ahead and mark them. So we've got A and D. And now we have C and F. So, what's the measure of angle E? 74. And that's how it works. I'll put him in there, 74. So, are triangles ABC and DEF similar? Yes, they are. Because remember, similar figures, right? Angles are congruent, sides are proportional. So, let's say yes. Let's write our similarity statement. Triangle ABC, whoops, is similar to triangle DEF. All right, let's take a look at 2. So we've got a bow tie working. Well, you know one set of congruent angles, and what are they without doing anything? The verticals, okay? So here's another pattern, you guys, that y'all are going to carry with you from the congruent triangles. So let's mark them. And they gave us V and Y. So 2 pairs. So we can prove it. All right, so we got to come up with our statement. So let's do WVX. Similar. Oh, y'all, hold up. Go back to this top one up here. I just noticed I messed that up. Go back and change that if you wrote down what I did. So triangle WVX similar to triangle, that would be ZYX. Questions on that one? And it also goes back to if you know 2 sides of the triangle, or no, 2 angles of the triangle, you can always find the third. Okay. And now we're going to look at the side-side-side similarity. So if you can prove that all 3 corresponding sides are proportional, then they are similar. So let's look at 3. So we have triangle QPR and TSU. All right. Can you see a correlation from little to big?
Yes.
Yes. Okay, so 3 corresponds to which side? Okay. 4 to 8, and then 5 to 10. 3 ways you guys can do this. Okay? You can, if you can see a quick reducing, you can reduce all of them. If that's not very straightforward, you can do the cross products to see. Remember, the cross products have to be equal to each other, or you can just literally just find the just do the actual division and find the ratio amount. Okay, but if but this one's a real quick. What are they all going to reduce down to? They're all going to reduce down to 1/2, right? So that's a quick one. So that would be a real quick one to reduce. They're not all like that. So then they are all 1/2. So is that enough to prove that they are similar? Yes. All right, so let's write our statement. So triangle QPR similar to triangle TSU. And let's look at 4. Okay, let's start with the 30. What does 30 correspond to? 24. 32. 25. And then 35. Oops. 28. All right. Well, we could, that 30 over 24, we could reduce that by 6. If we did that by 6, we'd get what? 5 over 4. And then if we come over to the 35/28, could we do 7? Could we do 7? So that would be 5 over 4. Now let's go to that middle one. We have 32 over 25. Can we reduce him? No. So, are these similar? No, because you're not getting that same ratio for your middle one there. So this would be no. And then our last one, our side angle side. Remember that the angle has to be where? Included. Remember that the sides literally form the angle. Okay? So let's take a look at this one. So they gave us K and N. So the sides that form K are these two, and the sides that form N are these two. All right? So is the angle in between included? Yes. Okay, so let's set it up. So we're going to have 8 to 6, and then 20 to 15. This would be a real quick cross product. Let's do that. If we multiply 6 and 20, that's going to give us 120. You can see that one real quick. And then 8 times 15. 120. Okay, so that's another way you can do it. I would not necessarily do that with the 3 sides. It would be a little time consuming, but the 2 sides, it's pretty quick. All right, so yes on this one. So triangle JKL, similar to triangle MNP. And you can, as you see number 6, that little tips popping back up again, okay? And you'll see them a lot. You notice that they already gave you the links, right? If they don't do that, you have to do it, okay? To keep these straight. All right. Oh, we need an angle. Do we have an angle congruency here?
Yes.
Yes, we do. A is going to be congruent to A. Right? So then what do we need? We need these sides right here. Okay. All right, you can start with little triangle or big triangle. What's your preference? Big? Okay. So that would be AB. So AB is what? 25. To little? 15. And then back to big. AC? AC? 21. To little? 12. Okay. So it looks like we could reduce 25 and 15 by 5. That would give us 5/3. 21 and 12 we could reduce by 3. 7/4. So, yes or no? No.